Okay, quick review of something that it's been months since we've gone over this. But it does have to do with electricity, and it does have to do with magnetism, because these are electromagnetic waves. Okay, so just a quick review before I get into what I'm going to show you here. The distance between a crest and a crest is called a wavelength. Okay, so the wavelength of wave B is bigger than the wavelength of wave A, obviously. So we're talking about radios in this particular situation, radio waves, which are a type of electromagnetic radiation. If you need a quick review of that, you can go back in your notebook. But I have my antenna right here that's going to go down into the house and let me listen to radio stations. And this is a point in space. So just to go over frequency again, these are both traveling at the same speed. They're both traveling at the speed of light. But wave A has a higher frequency. Frequency is the measurement of how many crests are passing this point every second. So A is going to have more crests passing by this point every second compared to wave B, right? So the bigger the wavelength, the lower the frequency. And frequency, again, is measured in hertz. If you look on your radio, it'll say hertz. Sometimes it'll say megahertz, depending on what, how many crests we're talking about. Okay, but these waves, it's hard to imagine, but it's true. These waves, because they're actual forms of energy, are going to vibrate this antenna back and forth. Okay, we don't see that because it's traveling at the speed of light. But it does actually vibrate these this antenna, and we can take that vibration and we can convert it into sound, and we can listen to the radio. Okay, so I have here a what's called crystal radio, and this is a project I used to do with students when I first started teaching. This is a fancy example of it. They used to use like toilet paper tubes and paper towel tubes to make this, and I'll explain what this is in a second. But this is how it works. So I have my antenna, and this is the schematic electricity diagram symbol for antenna, and I put the symbols on here just to make it all super fancy, because you know that's how I roll. But this is vibrating. We can't see it, but the antenna is indeed vibrating, and it's sending those vibrations down to this circuit. Okay, so I have my circuit diagram, and it is a circle, right? Which means I'm going to get an electric current from it. But I need one thing to make sure that I get a current. So the vibrations come down here, and here's our variable resistor, which is actually our tuner. This is the diode, which actually, you know what, I'm going to come back to this, because this is the most important part of the radio. This is what makes the radio work, is this little tiny thing called a diode. It goes into this is a resistor. It's a 10,000 ohm resistor. It's crazy strong, but that's why I have resistor here. This is the schematic diagram for headphones, and I have my headphone right here. It's a piezo headphone, which is really sensitive. It doesn't work on magnets like a regular microphone does. It works with vibration, because we're working with vibrations. And then it goes into a solenoid. This is any coil of wire is called a solenoid. And actually, I hand wrapped this myself, and it's made out of the same wire that I was using for my motor, right? This is ceramic wire. So this is probably a couple hundred feet of ceramic wire around this. Which is a really, I mean, it's a long wire, right? So the longer the wire, the more frequencies I'm going to be able to get, because I'm going to be able to fit more wavelengths into this coil, right? So it goes into the coil, and that vibration is going to create a magnetic field inside this tube, right? And it comes back out. Now, in order for electricity to flow, it has to have somewhere to go. And where does electricity want to go? It wants to go to the ground. So I have this wire right here that's attached to a water faucet, because water pipes always go to the ground, and because the electricity wants to go to the largest surface area, and the largest surface area we have here on Earth is the Earth's surface. So I'm going to make this go down to the ground so that I get an electric current. Here's the problem though. This is vibrating back and forth, which is creating this kind of current. It's called alternating current. Alternating current is where the current goes back and forth. That's AC. And direct current is where it's just going straight through the wire, like in a battery, and that's called DC. So if you ever wanted to know what the band name AC/DC refers to, that's what it refers to: alternating current, direct current. But this is the golden part of this radio. It's called a diode, and what it is a one-way dam for electricity to flow. So I've got this vibration thing going on, which isn't a current, it's just a vibration. What this does is I'll get a vibration in one direction, but it's a one-way dam. It won't let it go back. So I have vibration forward, 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 and I get on this other side an actual electric current, okay, which is powering this thing. It goes back around through the coil and then out through the ground. This resistor is here to concentrate the electricity through the headphone. But that's it. That's the whole thing. This variable resistor right here, I can move it across, and by going to different, right, these are all different lengths of wire, right, which is all going to give me different frequencies. So I can put it across this wire, and depending on how long the wire is, when this thing stops on it, I'll get different frequencies. And I don't know if you can see this or not, but this strip right here, this is where I've taken sandpaper and rubbed off the sand, or rubbed off the glass on the ceramic wire so this can make contact with it. The rest of it's still covered with glass to isolate one wire from another. So this is how you tune it in, and what you're doing is actually tuning it in to longer sections of wire to get different frequencies, okay, to get different wavelengths, okay. So there's no batteries. It's completely powered by the vibration created in the wire, and it works pretty good. Trying to tune into a station. Nope, here we go. I'm going to hold it up to the microphone of the camera so you can hear it. That's a local radio station. The antenna I've made longer ones that go all the way across the backyard, and I can pick up stuff from Sacramento with this thing. But that was just a local radio station. I think it was KPay, which is a sports radio station here in town. Yeah, see. Anyway, it's kind of a cool project you can do at home. These are crazy cheap. The resistors are also cheap. There's also easier ways to make this radio. Ultimately, all you need is a coil of ceramic wire and a diode. You need some sort of ground. And for those of you going into like electrical stuff, green wire is always ground. But that's it. Okay, there's way more simpler ones online, but I like this one. It's really super portable and sturdy. So anyway, hope you guys got something out of it. Kind of trying to link what we've gone over this year into some projects that you might want to do. Electric motor, crystal radio. Anyway, hope you enjoyed it. Thanks for watching.